This water should be boiling instantly, but instead it's gliding across the surface, completely intact. It isn't just surviving the heat, it's moving across it as if something underneath is pushing it away. Look underneath. The water barely touches the metal. There's a tiny gap between the drop and the heat moving with it. And that gap shouldn't exist. The surface is hot enough to boil water instantly, yet the drop keeps sliding, almost untouched. Now make the surface even hotter. You'd expect the water to disappear faster, but instead the drop becomes harder to touch. And now it moves faster. The hotter the surface becomes, the less the water seems willing to touch it. So what is pushing it away? Maybe the heat isn't destroying the water. Maybe the boiling itself is creating a barrier, a thin layer of vapor keeping the drop away. So if boiling is creating the barrier, what exactly is happening underneath the drop? The bottom of the drop is boiling away first. That tiny amount of vapor is what separates the water from the metal. The vapor can't escape fast enough. It builds a thin cushion beneath the drop. And it isn't a solid barrier. It keeps forming, escaping, and forming again as the drop moves. But this doesn't happen on every hot surface. On a cooler one, the water touches the metal directly and disappears. That difference is the clue. The surface doesn't simply need to be hot. It needs to be hot enough to change the way the water touches it. Push the temperature high enough, and the behavior suddenly changes. The contact breaks. Once that vapor layer becomes stable, the water stops losing heat the way you'd expect. The heat is still there, but direct contact is gone. At this point, the mystery seems solved. The water has its cushion, but that cushion has a limit. Because if that cushion collapses for even a moment, the water finally touches the heat. But here's what nobody tells you. This miracle has a border. Just below that threshold, the droplet dies on contact. Cross it, and the behavior changes. It isn't just hot, it's hot enough that the water never gets to touch the metal. The bottom flashes into vapor, and that vapor becomes a wall. Heat is still reaching the drop, but the vapor changes how the heat gets there. The droplet sits on an insulator made of its own death. And the wall isn't still. Underneath, water keeps boiling, feeding the cushion breath by breath, until it doesn't. One touch, one cool spot, one grain of dust, the layer buckles. Contact returns, and reality, without the trick, comes back in a blink. Every floating drop is living on borrowed heat, and borrowed heat always runs out. Everything you just learned just broke. The rule you trusted was only half the truth. A violently cold drop skating on metal that doesn't even look hot. Same levitation, wrong direction. Hot drop, cold drop, same floating. So it was never about hot. It's about a violent temperature gap, not the heat you see, the difference, and which side of that gap boils first. Before, the surface was boiling the water. Now the drop is boiling itself. Same shield, opposite engine, different source, same protection, a thin skin of vapor that refuses contact no matter which way the heat flows. And the moment that gap fails, contact wins, every time. Not how hot, how extreme the difference is, and whether vapor can outrun contact before the liquid touches. First half taught you to see the cushion. This half shows what the cushion really is. One law, two directions. Not magic. A force field made of phase change. Vapor under pressure. No glow, no fire, no molten stage lights. Still refuses to touch. We thought heat was the hero. It wasn't. The gap was, all along. The cushion appears when liquid and surface are so mismatched that vapor gets there first and builds a wall before contact can. If vapor can build a shield, what else can it hide at the edge of a drop? The drop isn't the mystery anymore. The boundary is. That's where the next secret lives. You were looking at the drop the whole time. The secret was never inside it. It was the skin, a wall thinner than a thought, built from vapor the instant two temperatures refused to meet. Go back. The hover, the collapse, the cold that floated like fire. Same law. You just met both faces of it. Heat was never the hero. Cold wasn't either. The gap was. And the boundary is where the gap becomes a shield or disappears. One rule for the whole film: when the difference is violent enough, matter builds a wall before it can touch. So the next time a drop refuses the surface, don't ask how hot. Ask what is living in the line between them. That line is still hiding something.